Today we're going to look at section 2A, understand, solve, and explain. So our goal here is to solve some problems. We're going to do some problem solving techniques. And so we're going to use this acronym USE, understand, solve, explain, to get us through from beginning to end of a problem. So our first step is to understand. So read the question and what are they asking? What do they want us here? Think about what are they asking us to do. Think about it visually. Draw a picture if we need to make sense of what it is. Ask yourself, what should the solution look like? If they're asking how much something cost, then I know my solution should probably be in dollars, okay? And try to think about, okay, how can I get from the given information that I'm given to the solution that I'm trying to get to? So continue revisiting this understanding of the problem to make sure that you can get through it. The second step is to solve, the S, solve the problem. So you go through your problem, you've already understood it. Think about what data that I have and what information is given to me, and begin to put together how you might solve this process and go through the process of solving the problem. Okay? Make sure you're checking your steps, avoiding any errors as you're going through your problem, and recalculate or reevaluate as you need to make sure you're getting to the solution that you want. The last step, a lot of people don't think about, the explain part. Do your results actually make sense? So when you're talking about your problem, like I say, if you're talking about the cost of something, does it make sense? Is it reasonable? If you're talking about the cost of a computer, is it reasonable that you get an answer in, say, $10 or $10 million? So is this a reasonable answer? And sometimes if you don't, you might have to go back to the U and the S, the understanding and the solving, to make sure that you get to your explain. And so make sure that your solutions are clear and concise, and always think of them as a complete sentence. It cost this many dollars to purchase a laptop. So in this section, we're going to think about what's going to help us to solve these problems, or to think about the units. And so the units are the quantity describing what the quantity measures or counts. So we want to know, what are we talking about here? So if we're talking about adding apples and oranges, if we're adding apples together, 3 apples to 4 apples, then the units is apples. Okay? If we're talking about how fast a car is traveling, it might be, say, miles per hour. Okay? Or we might have apples. And then if we're talking about oranges, the unit would be oranges. We'll make that miles per hour look better. All right. And so this whole section, we're going to talk about unit analysis. And this is the process of working with the units to help us to solve problems. So keep in mind, just like if I have a 3 divided by 3, it equals 1. It equals 1. Okay. Those are the same. And if this were, say, 3 meters divided by 3 meters, the 3's cancel, as well as the units of meters, which is 1. And so therefore, it doesn't change my problem. So our goal is I'm trying to change, say, from one unit to another, we want our units to cancel by something being in the numerator and the denominator to help us to do so. So we're going to go through this acronym USE to solve some problems. So you're buying 30 acres of farmland at $12,000 per acre. What is the total cost? So the first thing is, let's understand. So what is the question asking us? It's asking us about total cost. So we expect our answer to be in dollars. Okay? The S says to solve. So let's think about what information was given. Okay? They gave us that we have 30 acres. We want buying 30 acres. And it costs $12,000 per acre. And so what do we notice here? Right? If we say we have 30 acres and then it costs $12,000 per acre, then you can think of this as this over 1. I have an acres in the numerator and an acres in the denominator. And since we're looking at our units, right, we notice the only unit left is dollars. So when I multiply through, I get $360,000. And so now when we explain, we found that purchasing 30 acres of farmland at a price of $12,000 per acre will cost a total of $36,000. Okay? And again, think about, does this make sense for what we're talking about? So our next example says we want to show our operation in units clearly to answer the question. What is the total distance traveled when you run 7 laps around a 400-meter track? Okay, so going through to the solution, we're going to use that same U. So understand what they're asking. I have to go around a track 7 times, and to go all the way around the track, it's 400 meters. All right, so let's look at the information we are given and clearly talk about what we have. So we want to go 7 laps, okay, times each lap is 400 meters per lap. When we say per, we do division, all right? And so my laps end up canceling. We notice the unit is in meters, and so we see here my laps cancel, right? And we multiply this out, we get 2,800 meters. So when we're talking about these units, we're going to think about some key words that will come up. So I just mentioned that per, when we hear the keyword per, then the operation is division. And so, for example, it might be miles per hour, means I'm dividing miles divided by hours. Okay. If I see of or a hyphen, okay, of means to multiply. And so if we read this one, it says kilowatt hours. We just read this kilowatt hours. It means that I'm multiplying the kilowatts times the hours. This is the measurement of energy, say, in your home. If I'm squaring something, to square it, that means I'm raising it to the second power. So if I'm multiplying the units feet times feet, it's the same thing as feet square or square feet or feet squared. Likewise, cube or cubic means I'm raising to the third power. So feet times feet times feet is feet cubed or cubic feet. Okay. So when we're multiplying, we're doing our problems and we're going through our units, not just our numbers are going to be multiplied or squared or cubed. Our units also have to be multiplied and squared and cubed. To help us to be able to change maybe from one unit to another, we're going to use what we call a conversion factor. And a conversion factor is a statement of equality that is used to convert between units. All right. So remember when I said if I multiply, say 3 times 1, anything times 1 does not change the value of the problem. So in this case, if I have, say, 12 inches is equal to 1 foot. So this is a given unit conversion. Okay. If I divide each side, okay, by 1 foot, excuse me, okay, then 1 foot by 1 foot cancels and I just get 1. So this leaves me with this conversion factor. Likewise, I can divide by the 12 inches and it gives me this conversion factor. So according to what I'm trying to go to or from, I choose which conversion factor is appropriate. Okay? 24 hours is equal to 1 day. So again, I'm multiplying by some factor of 1, which is our conversion factor, to assist us to get to the unit that we are trying to get to. So if we want to convert the distance of 12 feet to 9 feet to inches. So we're going from feet to inches. So we saw in our last slide, sorry, I don't want that yet. Okay, we saw in our last slide that 12 inches is equal to 1 foot. And we're starting with 9 feet. And we want to go to inches. So I know that I need the conversion factor that has the foot in the bottom. So I'm going to say 1 foot, and then I'm going to put my 12 inches at the top. Why do I do that? Okay, because I want my feet to be able to cancel. Now keep in mind, this is the same thing as multiplying 9 feet times 1, because we know that since these are equal to each other, that when I divide each side by 1 foot, this conversion factor actually equals 1. So it doesn't change my value. And so what do I have here? I'll do 9 times 12, which is 108. And again, we're converting to inches, so what should be left is inches. And we have inches. So here it is a lot cleaner than what I've written. So here's a cute little cartoon we'll go through. It's summer vacation, yay! 94 days without a single homework assignment or test. 94 days, that's 2,256 hours. Or 135,360 minutes, or 8,121,6,000 seconds. And looks confused. Of course, my math brain waits until now to show up. So we're going to go through this and see, is she indeed correct? All right, so we're going to start off with what we're given. We got 94 days of summer vacation. Okay, and our goal is she ended with seconds, so we want to see if her numbers are correct. So we know that 1 day is equivalent to 24 hours. Okay, and so now if I cancel my days, my solution is in hours, but we're trying to get to seconds, so we need to keep going. Okay, we know that 1 hour, and notice I'm putting the ones that I want them to cancel in the denominator so they'll go away, is equivalent to, 60 minutes. And so now my solution is in minutes. I'm going to go just a little further. We know that 1 minute is equal to 60 seconds. So the minutes cancel. And when I multiply this through, I'll do 94 times 24 times 60 times 60. And then in the denominator, it's just 1 times 1 times 1. So that's just 1. We don't have to do that piece. And we indeed, if you use your calculator, get the number that the young lady got. And we're going to always use our, units. And this would be seconds. Again, here it is, a little neater than me. Now I want to look at when we have to raise a power using units conversions that are raised to a power. So I will tell you that your textbook will have the conversions you need minus the time one. So the last example we did with the cartoon, we assume that you guys know the time, so it's not posted. I will give you on tests and quizzes the conversion factors. You do not need to memorize the conversion factors. Okay, so they'll be given to you as here. So 1 yard is equal to 3 feet. Okay, and so 1 yard is equal to 3 feet. Okay, I might want to get cubic feet, and so remember that in this case it's square feet. And so 1 yard, this is the 1 yard, is equal to 3 feet. 1, 2, 3 feet. All right, and so how many total square feet would that be? So you can think of the 1 yard is equal to 3 feet. We're going to just square both sides. And so 1 times 1 is 1. And again, if you do yards and you square, you have to square the unit also. 3 times 3 is 3 squared is 9. And we also have to square this also. So now I have a new conversion factor. And we can use this conversion factor to solve problems. So the original one will be given to you, but it might be square or cube, and you have to do the work to show the new conversion factor with the powers. So let's solve this one. How many cubic yards, how many cubic yards of soil are needed to fill a planter that is 20 feet long by 3 feet wide by 4 feet tall? So I got a planter. It's 20 feet long. Okay. All right. 4 feet tall, 3 feet wide. So this is the wide, this is the 3 feet, and then 4 feet tall. All right? So first I have to figure out what the volume is of this space. And so to do that, I multiply 20 feet by 3 feet by 4 feet. 20 times 3 times 4 is 240. And then I have to also do feet times feet times feet, which gives me my cubic feet. Okay. So once I have that, I want to know cubic feet, and my answer I want to get is yards. So now I have to think about my conversion factor, that we have 1 yard is equal to 3 feet, but we need to cube this. Okay. And in cubing this, I get a new conversion factor of 1 yard cubed, and 3 cubed is 27 feet cubed. Okay. And so doing this, okay, so now we're using this conversion factor of 1 cubic yard, excuse me. 1 cubic yard is equal to 27 feet cubed. And so since I have the volume of 240 feet cubed, I write that here. I know I want the feet cubed in the denominator so my feet can cancel. And then I have my answer in the cubic yards. And so this time I do the 240 times 1, but then I have to divide by 27. And my yards cubed will be my unit. And so here it's approximately 8.9 cubic yards, or yards cubed. For this next example, I want you guys to pause the video and work it on your own and see if you get the correct answer. So the length of the Kentucky Derby horse race is 10 furlongs. So horse races are measured in this unit called furlongs. How long is the race in miles? And I want you to use this conversion factor here, that 1 furlong is equal to 0.125 miles, to get your solution. So pause the video at this time to get the solution. So now you can see the solution by going through the next couple of slides and making sure you got that the race is 1.25 miles. So I want to look at the metric system. So when we talk about the metric system, back when, I guess I don't say ancient times, but our goal is to standardize units. When we say the word standardize, it means that everybody agrees on the same meaning. So a standardized test means that everybody has the same information and should be able to take these tests. So we did this because back in the day, for instance, if we were talking about a foot, this was the length of the foot of the king. So this is the length of the king's foot. So you can imagine what the issue might be if we have a little small king, then he might have, say, maybe a 9 foot or 9 inch foot, but that constituted a foot. But when he was no longer the king, it changed to the next one. Okay, an inch happened to be the width of the king's thumb. All right, and a mile happened to be 1,000 paces of the king. So if he had short legs, it's a shorter distance. If he had longer legs, but it's not standardized because as the kings changed or in different locations, it's not the same. And so we've come up with this international metric system to solve this problem. This is in the late 18th century. And so we're going to come up with some kind of standard measurement. And so we're going to look at, so the meter was what we're going to use for length, which we're going to use abbreviation M, kilograms for mass, which we're going to use kg. For time, we're going to talk about seconds. And for volume, we're going to talk about liters. Okay, and we use the capital L. So here's some common metric prefixes that you can use, that you'll be using. So deci, centi, milli, but these are all common meters. Sorry, go back. Okay, and then the larger ones above the meter are the deca, heca, and down to the tera. So we want to convert 2,759 centimeters to meters. Okay, and so if you look at the last chart, it says that centi means 10 to the negative 2. So what does that actually mean? That means that 1 centimeter is 10 to the negative 2 meters. Okay? And of course, remember 10 to the negative 2, anytime I have a negative exponent, that means that I can bring it to the denominator and it becomes a positive exponent. Okay? And so that's really 1 over 100, meters. Okay? If I have 1 centimeter is equal to 1 over 100 meters, I can multiply each side by 100, so I don't have to have fractions. We know how you guys love fractions. And we get this measurement here. So when I see that centi means 1 to the negative 2, I can convert it using these conversion factors I have listed, and I get to that 100 centimeters is equal to 1 meter. So going through this, we start with our 2759 centimeters, and this is the conversion factor that we're going to use. And since I'm trying to get rid of the centimeters, I'm going to put the centimeters opposite, so then the denominator, and I'm left with meters. So I end up dividing by 100, and I get my solution of 27.59 meters. Again, you will be given these charts, so you do not have to memorize the conversions. So again, I want you to pause, look in your book to see what the conversion factor is and solve this problem. A marathon running race is about 26.2 miles. How far is this in kilometers? Okay, so once you've paused, you could go through and look at the conversion factors in the text, and you should get 42.2 kilometers. Now we're going to move to temperature units, okay? And so the Fahrenheit scale is what we usually use in the United States. And what is this defined as? At 32 degrees Fahrenheit, water is where water freezes, and 212 Fahrenheit is where it boils, all right? And so everybody else in the world, we're just special. They use Celsius. And so their freezing point is 0 degrees Celsius and their boiling point is 100 Fahrenheit. Okay. Now in science, we use this temperature called Kelvin. Right. And so Kelvin measures, is similar to Celsius, but the 0 point corresponds to this negative 273.15 degrees Celsius. Okay. And so the temperature of 0 K, and so K is used for the unit for Kelvin is what we call the absolute zero. And when we write it, we do not write the degrees symbol when we're using the Kelvin scale. So here's just representation of the Fahrenheit, Celsius, and Kelvin. They're absolute zeros, where the water freezes and where water boils, to give you an idea. But these are all, we can convert from any of these temperatures to another, which is what we're going to do next. Okay. So we do so by using these conversion factors. If we want to go from Celsius to Fahrenheit, we use the formula. F is equal to 1.8 C, which is our Celsius plus 32. From Fahrenheit to Celsius, we use this formula here. From Celsius to Kelvin, we use this formula here. And from Kelvin to Celsius, we use this formula here. Again, you will be given these, so you do not need to memorize them. So let's look at this example here. The average human body temperature is 98.6 degrees Fahrenheit. What would this be in Celsius and Kelvin? So at first, we're going from Fahrenheit to Celsius, okay? And so, doing so, we can use the formula that was given to us, that Celsius is equal to Fahrenheit minus 32 over 1.8. We plug in what we have for our Fahrenheit into our F, and then we simplify. And we notice that we get 37 degrees Celsius. Okay. Now, for Kelvin, we saw that we have Kelvin is equal to Celsius plus this 273.15. So notice I can't go straight from Fahrenheit to Kelvin. I have to do this Celsius in between, because there is no formula that we have that goes from Kelvin that has a Fahrenheit in it. So once we have this, we use this Celsius degrees. So we do the 37 degrees Celsius to the 273.15, and this gives us our Kelvin value of 310.15. Now we're going to look at currency conversion. So if we want to change from one currency to another. So unfortunately, we aren't allowed to go out of the country now. But when we are, again, this is very useful when traveling internationally. Okay. But let's see, you're be given a chart. Keep in mind, exchange rates change. So these are the exchange rates for February 2013. I think your textbook has an updated list. So you're going to use the ones in the textbook and not the ones on this chart. Okay, for class, we will use this here for right now for this video, but you use whatever is in your textbook. I think it might be updated to 2017. Now, of course, according to how the country is doing and what's going on, values change. So sometimes the US dollar is strong, but when we aren't doing so well politically, it might be what we call weak. All right, so let's see how we read this chart. When it says dollars per foreign, this means that this is the dollar amount per foreign unit. So for instance, this means that this is for euros, $1.320 is equal to 1 foreign unit. So in this case would be 1 euro. When I see foreign per dollar, all right, this is the foreign amount. So 0.7576 euros is equal to $1 amount. Okay. Now, when we're doing this, say for the euro, that's the example we're going to look at next, you do not use both of them. Okay. My advice is to choose a column and stick with it. Okay. We do not use both of these values. Okay. Some people want to say this is equal to this value. They are giving the same information. So no. Remember, dollar per foreign means this is the US dollar amount per foreign unit, per 1 foreign unit, 1 foreign unit. And this is the foreign amount. So this would be the British pound to $1 per $1 US dollar. So we're going to look at this example. At a French department store, the price of a pair of jeans is 45 euros. What is the price in US dollars? So we're going to euros to US dollar. So the chart was given to us this. This was our dollars per foreign. And then the other is our foreign per US dollar. Okay? So I'm going to show you that you get the same answer in either way. So let's look at this conversion factor. So remember, we can put either on top of each other to equal 1. So these are the equivalent conversion factors. But since I'm going from 45 euros, I want to use the one that has the euro at the bottom. And so my euros would cancel. And then I get $59.40. Now let's look at the same problem. We had 45 euros. Okay? But what we used the first time was this conversion factor. So now we're going to use this second conversion factor here. And so now what goes at the bottom is the euro, which is 0.7576 euro. Why do we choose that? Because we want the euros to cancel. Is equivalent to $1. Now when I divide this out, you still get the 0.40 that we've gotten before. So my advice is, again, choose one of the columns, stick with it, and only because you'll be given the full chart. So you'll have to decipher on your own which one to use. All right. We're going to end by having you do this example on your own. Okay. And so a gas station in Canada sells gasoline for CAD 134. So this is CAD is for Canadian dollars. So the Canadian dollar of 134. what is the price in dollars per gallon? So you're going to use the exchange rates from the table before, okay, to figure out how we would do this problem. Okay, so if you've gone through it, I'm going to go through it with you. This one has 2 units. So we have CAD 134 says per, we said was divided by 1 liter. And we're looking for dollars per gallon. So first thing is we need to change this CAD to US dollars. So I've chosen to use the first column, and that gives me that the dollars per, let's do this, per foreign. So now I see my units would be in dollars per liter. So I have to do an additional conversion. And this additional conversion is I now need to do liters into gallons. And so in your textbook, you'll see that 3.7854 liters, oh, excuse me, not 54, this is a liter here, is equal to 1 gallon. So my liters cancel. I'm left with the units of dollars and gallons. And when I multiply through, I get $5.10 per 1 gallon. And this is the solution to this problem. So again, you can read through this solution, okay? And you should get the same answer.